right, here's our video, standard deviation, and part one, right? We'll just do part one. Now, you could do the standard deviation on a calculator on the TI-84, but we're going to do that in the next video. In this video, we're going to do it by hand, do it the old-fashioned way. So again, getting our pen ready. This is just going to be part one, just an introduction to it. We'll do some simple problems. So what is the standard deviation anyway? What do you think it is? Well, it's a way of measuring spread in data and statistics, probability. So if you have a set of numbers, whatever the case may be for these numbers, you want to know how far each value is from the mean. Now, let's just do it because it's easier to write it out to give you an example of it. So let's get a clean page here. Get a clean page. And why don't we start with red? We'll use red. So let's say let's use a baseball analogy first here. Let's say that we're looking at the runs per week of, well, let's just say the Mets. Right? Runs per week of the Mets. And let's say they played the whole week. Sometimes you have a day off, but we'll put in the days here: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and we'll add Sunday at the end there. All right, and let's say on Monday they scored, well, let's say they scored 2 runs, and on Tuesday, let's say 1 run, and Wednesday, maybe they had a good day, they scored 6 runs, and then they scored 4, and maybe Friday they scored 4, and Saturday they scored 3 runs, and Sunday they scored 1 run. So these are the runs per week. So the first thing we want to do is get the average, the mean runs. The mean is the average, right? And we're very used to average. We've been using it since our school days, right? You still use it. You want to know your average, right? So if we take this, to get the mean, we need to get the sum of all this, right? The sum. And this is a symbol for sum. It's the sigma symbol, sigma, Greek letter. And you're also going to use this lowercase Greek sigma. This is also sigma, but lowercase. That is what we use for standard deviation. That's the symbol for standard deviation. All right, so let's go back. We have all these numbers, all these runs for the week for the Mets, and we want to get the sum. And the sum is 21, right? If you add all these up, you get 21, and you divide it by the number of days, 7. So we know that the mean, and we're going to use another symbol for mean. It's another Greek letter, and it's written something like this, right? Without that dot, I just put a period there. So this is called mu. It's just the symbol for mean. And so the mean, the mu, you should just say the mean, because mu you can use in science also. The mean is 3. So that's the mean. So, but we're not done yet. So we have the mean, and now we're going to use that to calculate standard deviation. So let's put a line over here. Just make a little line down here. That was step 1, getting the mean. Step 2, using a Roman numeral over there. Maybe I'll change the color. Use yellow, clear it out a little. Step 2, you're going to take each number, each run, and you're going to subtract it from the mean. So we had 2, we had 1, we had 6, we had 4, we had 4, we had 3, we had 1. Right over here, right? These runs. And we're going to subtract it from the mean, which is right there, 3. 2 minus 3, 1 minus 3, 6 minus 3, 4 minus 3, 4 minus 3, 3 minus 3, and 1 minus 3. And then when you get that answer, put these equal signs in. You don't care if it's negative because you're going to square them, right? And when you square negative, you'll still get a positive number. So here you get the square root, you get -1, and the square root of -1 is just 1. And over here, 1 minus 3 is -2. -2 squared is 4. So if you keep going down the list, why don't you try that? Pause the video, see what you get. If you pause the video. Well, anyway, 6 minus 3 is 3, and 3 squared is 9. So 4 minus 3 is 1. 1 squared is 1. We have it again over here. 3 minus 3 is 0, so we just have a 0 there. And here we have our -2, and -2 squared is 4. Now you're going to add all these up. You're going to get the sum of what you just did. So we're going to get the sum again. That's the symbol for sum. What do you think the sum is? Get all those together. Just pause the tape if you need to. So when you get that, you're going to get a sum of 20. Now get the mean again. Now you want the mean again. So you're going to divide by 7. And the mean, remember that symbol for mean? That mu Greek letter symbol. If you divide this out, you're going to get about, let's put the about sign. You can use a calculator and get a lot of numbers, but it's about 2.857. So that's the mean. That was the first mean we used of all the runs. And this is the mean of all the numbers after we subtracted the runs from the mean. And we got 2.857. So that's step 1. That's step 2. Now to get the standard deviation, we're going to square root 2.857. And you'll get, if you put on the calculator, about 1.69. So 1.69 is the standard deviation. So this is what we write for standard deviation, that lowercase sigma, and we say 1.69. So let's do another example. So I'll clear this out. Give you a few seconds if you want to look at it again, or just rewind. I'll clear it out now. So let's keep with our baseball analogy. Why don't we keep yellow? Look pretty good. So let's say that, let's say we have another day in the week, Monday, Tuesday, maybe there was a day off on Wednesday, Thursday, and Friday. Maybe just for 4 days, maybe another team joins. Maybe let's say the Dodgers. Let's say the Dodgers, the Brooklyn Dodgers, right? The Los Angeles Dodgers, whatever one you want. So let's say they scored on, let's say on Thursday or on Monday, let's say they scored 2 runs, and then they scored 6 runs on Tuesday, maybe 1 run on Thursday, and 3 runs on Friday. So we have step 1. We got to get the sum. What's the sum? If you add them all together, you'll get 12, right? So when we get that, now we're trying to find the mean. We just divide 12 by 4, and we'll get the mean. Remember that symbol? Is 3. So that's step 1. Make a little box. We have the mean, the average of 3. Dodgers scored an average of 3 runs within that 4-day span, not including Wednesday because they were off. So on step 2, what should we do? Who remembers? Now we want to know how far each run is from that mean. So we have 2, we have 6, we have 1, we have 3. We're going to minus it from the mean. And what do we get? Well, here we're going to have a -1. We're going to square it. Here we're going to have 3 squared, -2 squared, and of course 0. So here we'll have 1. Here we'll have 9. Here we'll have 4. And here we'll have 0. So we want to get the sum of this. Remember that symbol? That's sigma. The sum of all that is 14. Then what do? We want to get the mean of this. We want to get the mean of that. And all we have to do is divide 14 by how much? What do you think? How many numbers are we using? How many runs? There's 4. And if we do that, we're going to get a mean of about, well, exactly, not just about 3.5. But we're not done because we have to get the square root of the mean, and that gives us a standard deviation. Standard deviation symbol, 1.87. Those are 2 examples. So what does this all mean? So the lower the standard deviation, that means that the numbers, the values, in this case the runs, the lower the standard deviation is, the more the numbers are clustered together. So if you see it on a chart, and in the next video we'll talk about a bell curve. Bell curve kind of looks like this. It's a curve. So if you see the numbers kind of like this, you see a bell curve like this, the numbers are very clustered together. That would be a low standard deviation. But a high standard deviation means that the numbers are very spread apart from each other. You might see something like this. So with a low standard deviation, more clustered together, and a high standard deviation, more spread apart. And I'll explain it in the next video when we talk about a bell curve, how this will fit with a bell curve. Also in the next video, we'll talk about how to use the calculator because you can solve this very easily on the calculator. All right, that's the video today.